All right, today we're going to be looking at some basic square root functions. And so I want to show you first of all just the very basic square root function, and this is not in your notes, but I just want to peek at this with you on your calculator. The basic square root function would be y equals the square root of x, like this, okay? So we're going to go just put that on our calculator just so that you can kind of picture what's happening here. I'll clear this out, and I have y equals the square root of x. Whoops, somehow that happened. Okay, I'm going to start over here. Square root of x. All right, there we go. Go ahead and hit graph. And this is what the square root function is. You notice kind of its end point right here is at 0, 0 right now, and it would keep going on forever and ever and ever in that direction. Not a straight line, it's curved, but that is the very basic square root function, okay? And so we're going to kind of peek at that and see if we can look at some different properties that are using that equation, okay? So first of all, I am going to look at the graph of y squared equals x. If we want to be able to put this into our calculator, we have to solve it for y. Our calculator has to have it say y equals something. And so when we go to our calculator, we would need to square root this. And when we square root it, we need a plus or a minus in front of it, and we'll talk about that in a minute. Basically, that means you have two functions. You have y equals positive square root of x, and you have y equals negative square root of x. And they both have to happen. We already know that positive square root of x starts at 0, 0. And then we'll plot some points and you can see how this happens in a minute, but it's going to go something like this. That's positive square root of x. And then negative square root of x will flip that same graph over the x-axis, and it will end up looking like this, okay? So if we wanted to see that on our calculator, just so you know, we would have to put in both the positive square root of x, and then I would have to go down here, and I would have to put negative square root of x in also, so that when it's solved for y, they both show up. And both of those pieces together make that equation that we started with right here, which was y squared equals x. Most of you aren't going to take the time to solve this on your calculators. I'm just telling you. Most of you probably will be able to get what's happening here by just making a small, short little table, okay? So this is what I'm going to tell you. You're going to pick some numbers, and I would pick numbers that kind of come out pretty. Notice that we're dealing with square roots, so I would pick numbers like 1, 0, 4, 9, 16, numbers like that, okay? So what I'm going to do is I am going to pick, let's say I am going to pick 1. Well, no, I'm going to pick 4 for x. So if I pick 4 for x, then I need to think about what number squared makes 4. And this could either be 2 or it could be negative 2. Okay, 2 squared makes 4, negative 2 squared makes 4. If I pick 9 for my x value, then I need to think about what numbers squared make 9. And it could be 3 or it could be negative 3. So that's why we have plotted the points for 2 and for negative 2, because when x is 4, y could either be 2 or negative 2. When x is 3, when x is 9, y could either be 3 or negative 3. When x is 1, y could be 1 or negative 1, etc., etc., etc. But this is what we get. You can see that this is actually not a function because it does not pass the vertical line test, but it is the equation right here, okay? So we want to look at what our domain and our range is. Again, domain means you're going to take a vertical line and you're going to drag it this way and see where you start touching the graph. So you start touching the graph when when your x value is 0, and then you'll touch it all the way over there to positive infinity, okay? So in set notation, it'll look like this, x such that x is greater than or equal to 0. In interval notation, it will go from 0 to positive infinity, okay? Then your range, you're going to draw a line and go this way, And I know it doesn't look like my graph is touching right now, but if I were to continue going down forever and then be able to extend that blue line, eventually they're going to meet somewhere off the screen in the bottom right-hand corner. So it is touching the graph. It's touching the graph. It's touching the graph. It's touching the graph. It's touching the graph. There is still, even up here, it would be touching the graph eventually way off the screen in the upper right-hand corner of the room. Okay? So my range in this case would be all reals. There's no number that your y value can't be. And then for y, it would go from negative infinity to positive infinity. Okay, so that's how that works. Then these next ones are going to involve taking the basic square root function. And again, that basic square root function, if we get rid of this one, the basic square root function looks like this, okay? These will be very similar to your absolute value functions where it will do the same kinds of things, okay? So this plus 3 right here will take the graph and it will take the basic absolute value function and it will move it up 3. Again, if you can't picture that, then I would suggest kind of making a table. Now, when you make a table, you can only take the square root of 0 or any positive number, okay? If I can't pick x to be -1 because I can't take the square root of a negative, that's illegal. So the smallest number I can put in for x is 0. When I put 0 in for x, the square root of 0 is 0, plus 3 is 3. Now, I'm going to choose to pick pretty numbers. I'm going to pick 4 for x next, okay? The square root of 4 is 2, plus 3 makes 5. If I put 1 in, the square root of 1 is 1, plus 3 makes 4. So if I go ahead and plot those points, I have 0, 3, and 1, 4, and 4, 5. So you can see what it did is it took that basic square root symbol and or square root function graph, and it moved it up 3. That's all that it did, okay? So my domain now, if you draw your vertical line, okay, your domain, I start touching the graph when my x value is 0, and I go all the way to infinity. So my domain would be the set of all x, such that x is greater than or equal to 0. Or in interval notation, I can go from 0 to positive infinity. Okay? My range, where you start touching the graph there, if I go this way now, I am not touching the graph, 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 until I have a y value of 3 or bigger. Okay? 3 or bigger. Notice how that plays out in the equation. Notice where that 3 came from. It's right here in the equation, okay? So it kind of helps to picture the graph and then see what happens to the equation. This one, and we'll put these in our calculator too, but this time I'm going to take the basic absolute value, or the basic square root function. I am going to, and when it's inside the radical, it's going to do opposite of what you think. So this is going to move that graph left 3, and it's going to move the basic graph down 5. Okay? If it had a negative in front, it would flip it over the x-axis, but it doesn't. It's going to go left 3 and down 5. Again, we're going to pick some handy-dandy little things that x can be. Now, we have to be strategic because underneath that radical symbol, we cannot have a negative number. The smallest number we can have underneath that radical symbol is a 0, which means the smallest number that x can be is -3, because -3 plus 3 makes 0. The square root of 0 is 0, and then if I subtract 5, I get -5. Okay? If I want to take the square root of 4, let's say, then, or if, let's say I want to take the square root of 1. So what number plus 3 would make 1? I'm going to go to -2. Okay? If x is a -2, then I have the square root of -2 plus 3, which means I have the square root of 1, which is 1. And then if I subtract 5, I get -4. Okay? And then if I put 1 in here, the square root of 1 plus 3 is the square root of 4, which is 2 minus 5. It gives me -3. So You don't have to do this with tables if you don't want to, but you can certainly do this on your calculator, or you can kind of just think logically, okay? So it took the basic graph and it moved it left 3 and down 5. And those are my points that I can plot, okay? I'll have you put this into your calculators also so that you can kind of peek at this. We will do the square root of x plus 3. And now right arrow over so you're not underneath your radical anymore, because the rest of this isn't underneath the radical. And then subtract 5 and go ahead and graph it. And you can see that you'll get exactly what we did. If you want to look at your tables are kind of helpful too sometimes. You can see that your tables are here, so that would also give you some points to plot. And notice that you're getting errors when your x values are -4 or smaller. Actually, smaller than -3, you're going to get an error. But here's some points to plot too if you want to think about it that way. Okay? So in this case, our domain starts right here. This is sort of our magic spot. I have an x value of -3 there, okay? So my domain will exist as long as my x is greater than or equal to -3, because it exists to the right of that spot. Or I could go -3 to infinity, okay? And then your range at this magic spot down here, the y value is -5, and it exists for everything above that. So y would be greater than or equal to -5. All right, and then lastly, this one I want you to notice is slightly different because it's x equals the absolute value of y plus 3. Now, I didn't make a graph, but I'm just going to tell you you're going to have some stuff like this in your accelerated math possibly. So I want you to be able to think about this, okay? Here, if we were to do this with a table, we would want to actually probably pick y values instead of picking x values this time. Again, the smallest number you can take the square root of is 0. So if y is 0, then I have the square root of 0, which is 0, plus 3 gives me an x value of 3. Okay? If I have a y value of 1, the square root of 1 is 1, plus 3 gives me x to be 4. If y is 4, the square root of 4 is 2, plus 3 is 5. Okay? I cannot put this into my calculator actually because I don't have this solved for y right now, and I'll talk about that in a minute. But when we plot this, this is what this would look like. 3, 0, 4, 1, 5, 4. And it's going to look something like that, okay? Now, when we try, if we wanted to try to put this into your calculator, you would have to have this solved for y. So then when I solve this for y, I would have to subtract 3, and then I would square both sides. And when you square both sides, you have to take that quantity and square it. So I would have y equals x minus 3 squared. And then what happens is when you put that into your calculator and you graph it, in fact, I'll show you this really quick. All right, I have x minus 3, which I'm going to square. And I'll graph this. Okay, what's going to happen is it's going to show you a parabola like that when really the parabola is not the right answer, okay? This half of the graph can't exist. And the reason it can't exist is this. Though that half of the graph, again, the smallest number that you can take the square root of is 0, okay? The square root of 0 is 0. And then when you add the 3 to it at the end, the smallest that this quantity can be would be 3, because the smallest y value I can plug in is 0. So the smallest quantity that that value can be is 3. And so then when you go back to your calculator, this has an x value, let's say right here, of 2. Well, I can't have an x value of 2 because that's not legal. Okay, so sometimes you just have to think logically, and your calculator is not the end all be all. So I want you to just kind of think about that. For this particular graph, I'll just do this in interval notation. My domain would go from 3 to infinity, and my range would go from 0 to infinity. Okay? If the equation was the other way around, like y equals the absolute value of x plus 3, if it was like that, then these two things would be switched. Okay, so if that helps you think about this, the domain and the range are opposite of what your domain and range would be if your x and y were switched. Okay, and you're used to seeing the basic square root function as y equals the square root of x and then manipulating it. But if it gives you the other way around, then you have to take what it would be normally and switch the domain and the range. Okay, so hopefully that will help.